Hi guys, please like, share and subscribe. And if you want full course for any actuarial subject, visit theactuarialguy.com or WhatsApp on this number. Thank you.
Hello and welcome, guys. This video is a part of my series on the errors in the Institute of Actuaries of India exams. Now, there are two purposes of this series. The first one is to point out to the II stakeholders that there are a lot of errors in the exams, and this needs to be fixed immediately because I think this is hugely problematic for the credibility of the institute and the exam system. Secondly, when a lot of you practice past exam questions, you would not be able to get the answer right for these questions. You would not be able to get one of the options as your answer. So, this is your guide to making the relevant changes to the question in order to get the correct answer. In case any of you feel that there is a problem with my suggested error in the question or my solution, you can reach out to me directly and we can discuss. Thank you.
Okay, now let's look at this next question, which is again a Markov chains question, and there is a typo in this question. So I'll tell you what the typo is. In a genetic study, it was found that a gene appears in two forms, capital D or small d. Okay. An organism has a pair of genes which can be dominant, which is double capital D, mixed, which can be one big D, one small d, and then residual, which is two lowercase d's, right? So this is what you have got, right? Uh, a gene can either be dominant or recessive, or which they are calling as residual, or it can be mixed, right? These are pairs of genes that one individual has, right? Now, in any generation, a gene is derived from its previous generation, that is combination of two pairs of genes with equal probability, right? So what they're saying is that if you have some parent who's mating with a DD mating with a capital D, there are four possibilities here. This combines with this one, which is capital D. This first capital D combines with the second capital D, again that's a DD. The third possibility is small d capital D, and the fourth possibility again is small d capital D. So these are four probabilities, four possibilities with equal probability, right? Um, yeah, so that is how it will work, right? So that's what they are telling us. Now, given this, they are saying that an organism is always combined with a mixed gene type progressively through generations, right? So what they are saying is that one of the parents is always going to be capital D small d, right? That is how they are mating. So one parent can be any one of these, right? They can be capital D small d small d small d, but one parent will be capital D small d, right? Assuming the starting organism has a mixed gene type, compute the probability that the nth generation organism is with the residual gene type. Now, firstly, this is very similar to the first question, right? They want to know what is the general expression of, given something in the initial state, they want to know the general expression for being in a particular state at time n, right? But there is a typo here, okay? If you solve this, you won't get any of these answers. Again, the answer would become none, which they have not even given in their answer key. So here, assuming that the starting organism has a mixed gene type, this is incorrect. They You will only get one of these answers if you assume that this individual has residual gene type. So assuming that this individual has residual gene type, then uh, compute the probability that the nth generation organism also has a residual gene type. That is what you can compute, and that will come out to be one of these options, right? So now how do we do this, right? So see, the probability matrix would look somewhat like this. So you have three cases. Let me write the first one as capital D, then capital D small d, and small d small d. This is the order that they have given it in as well. Right. Now let's work out the probabilities. Okay, let's see what happens if a capital D individual mates with a capital another capital D. No, the question is what is the probability that you go from a capital D individual to a capital D individual. Now this one, how do you work it out? See, you have to assume that an organism is always combined with a mixed gene type. So one parent is capital D, the other one is this. Then what is the probability of getting this, right? So here what will happen is that out of the four possibilities that I showed you, in only two of them you would get capital D. That is this one combining with this one and this one combining with this one, right? So that is 50%, right? And what is the probability that it goes to capital D small d? Those are the other two possibilities, 0.5. This is 0, right? You can't go with this combination, you can't get small d. All four combination, none of them have small d, right? Second one, you have capital D small d, and the other parent is also capital D small d, because this parent always mates with another parent from nature, which is capital D small d. So now what would this be? So let's see. Let me actually write this out for you. So you have capital D small d with capital D small d, right? So this will be one will be capital D 25%. Then you will have capital D small d, small d, right? So this and this is 25%, this is 50%, right? So this is 0.25, this is 0.5, this is 0.5. And the last one, if you mate a small d with a capital D small d, then you will get a 50% here, you will get a 50% here, and this will be 0, right? You can work it out. So this is your probability matrix, right? Now you have to start with a residual gene type. That is, you have to start with 0 0 1, and then by the nth generation you want to get to one of these, so you will have to solve through the options, right? One interesting thing in this will happen is that you will get the steady state really fast in this, right? So this will settle down very quickly into something. Okay, let's see how does that work out, right? So let me just show you. Okay, so you have your x0 as 0 0 1, and you have your p as 0 0.5 0 0.50, 0 0.25 0.25, and finally 0 0.5 0.5. Now what will happen at the first transition? X1 will be equal to, it will just be just the third row, so 0 0.5 0.5, right? Now x2 will be equal to, the first row is 0.5 times 0.25, that is this one is 0.125, right? Then you have 0 0.25 plus 0.25, that is 0.5, right? And finally you have a 0 times 0 times 0 times 0.5 times 0.25, 0.5 times 0.5, so 0.25 plus 0.125, 0.375, right? And then your x3 will be equal to, so this will be your x3. Now what we need to do is we need to check which of the options satisfy these values of x1 x2 and x3. If multiple options will satisfy, then we'll get x4 and then compare. But most likely with three values you can validate all options in most of such questions, right? So now let's just start doing that. So let me go to the options. So these are the options that I'm looking at. Let's put them into the calculator. I'll start with option A, right? uh, so it's 2 to the power of, let me set A as 1 first. Okay, and I want to get the value as 0.5. That's the value. Let me just show you that quickly, what I'm talking about, which are the values I want to get. So I want to get the value that they are in the residual state, which is the third state. Okay, so at 1 corresponding to n is equal to 1, I want to get this value. N is equal to 2, I want to get this value. N is equal to 3, I want to get this value, right? uh that's what the question said, right? Like the probability uh, of being in the residual gene type after n steps, right? This is the general expression. So let's just check now. So the first one, if I put it in, let's store 1 to A. So shift store A, 1 is A now. And now let's type out the whole thing, which is 2 to the power of 2n minus 1. So n is A minus 1, right? Whole thing minus 1, close the bracket, right? And then this whole thing you add 0.5, and then you close the bracket and you do a 2 to the power of minus A, right? And this should give me 0.5. And okay, I think I've made yeah, this is correct only. Yeah, this is giving me 0.75. So option A is definitely incorrect. Okay, let's move on to option B. Option B, the only changes are this is 1.5 and this is 2 to the power of n minus 1. So A minus 1, right? This is the only change. Let's see. Again 0.75. This is also incorrect. Okay, let's go to option C. This is 2 to the power of minus A minus 1. That's the only change they've made, right? Let's see this. 0.375, right? This is also incorrect. Let's go to option D now. So that's how easy it is. See, all options get eliminated at the first value itself, right? A to the power of n minus 2. Sometimes you can just like calculate till the second value and do this. You don't even need to multiply the vector 3 times, right? But I'm just doing it to be on the safer side, right? Plus 1.5, 2 to the power of minus A. This is giving me correct 0.5. So D is giving me correct so far. So we'll check at A is equal to 2 and A is equal to 3 as well, right? So 2 shift store to A, right? Now what is this? 3 by 8, 0.375. This is also correct, right? So D seems to be correct for n is equal to 1, n is equal to 2. Now let's try n is equal to 3. This will confirm it. So 5 by 16, 0.3125. This is also correct. So option D seems to be the correct answer. So you can mark D. E, if you want to try just for the sake of trying. So the only change there is that instead of this 0.5, I've got a 1.5, I've got a 0.5, right? This. So this is 0.1875. This is wrong, right? So this gets eliminated. So D is your correct answer, right? But this answer you got only when I changed the question itself. There was a typo in the question. And that's why, today most things are sorted with II. They have MCQ exams, so the typing in Microsoft Word part is not there. Um, they're conducting exams 4 times a year. All of that is great, but such issues make II a problem, right? So yeah, that's what I'll tell you. Couple of questions every attempt are wrong. Here we have solved 4 questions, 2 of them are wrong.